Have you ever wanted to make electricity like out of thin air? Well, today we're going to do the next best thing. We are going to build a real, working battery using just a few lemons and some stuff you probably already have at home. Let's get right into it.
You know that old saying, right? Well, we're giving it a fun, scientific twist. This is all about turning a simple piece of fruit into an actual power source. And I promise you, the science behind it is just as cool as seeing it work. It's gonna be a blast.
So what's our big challenge today? It's pretty simple, actually. We're going to generate enough electricity from these lemons to light up a tiny LED. By the time we're done here, you'll know exactly how to pull it off yourself.
All right, any great project starts with getting your gear in order. Before we start building anything, let's quickly run through the simple materials and tools you're going to need to make this happen.
The list of materials is wonderfully simple. First, you'll need lemons, of course, which are going to act as our acid solution. Then you need two different kinds of metal to be our electrodes, some copper pennies and some zinc-coated or galvanized nails. And finally, just a bit of copper wire to connect it all together.
For tools, you'll just need some basic stuff like wire cutters and maybe some pliers. You know, tape and a marker can be handy for labeling things, but they're totally optional. And hey, a really important note. If you're under 12, please go grab an adult to help you out with the sharp parts of this. And speaking of that, let's talk safety for a second. This is super important. Once we're finished, please do not eat these lemons. The metals can actually seep into the fruit and you don't want to be eating that. And of course, just be careful with the sharp nails and tools. Safety first, always.
Okay, with our safety check out of the way, it's time for the really fun part. Let's build our very first battery cell. I promise it's way easier than it sounds.
First thing you want to do is take your lemon and give it a good roll on the counter. Press down on it a bit. This just breaks up the little sacs inside and gets all that acidic juice flowing. Next, take 4 of those galvanized nails and push them into one side of the lemon. You want to make sure they're all touching each other because they're going to act like one single negative terminal. Okay, now for the other side of the lemon, go ahead and make a row of small slits and then push in 3 or 4 copper pennies. These guys are going to be our positive terminal. Then, just coil up a little piece of copper wire and press it right into the lemon so it's making good contact with those pennies.
Now listen up, because this is probably the single most important tip of the whole project. You have to make sure the copper pennies and the galvanized nails do not touch each other inside the lemon. If they touch, you'll get what's called a short circuit. It's like an electrical dead end, and your battery just won't work at all.
And just like that, you did it. You've officially built a single-cell lemon battery. Pretty cool, right? But here's the big question. Is one little lemon powerful enough to actually light up our LED? Let's find out.
So, we connect our wires to the LED and nothing. It doesn't work. Kind of anticlimactic, I know. But don't worry. There's a very, very good reason for this, and it's all part of the process.
So, why the big fail? Well, it's pretty simple. One lemon just doesn't produce enough voltage. Think of voltage as like electrical pressure. It's the push that gets the electricity moving. Our LED needs a certain amount of that push to light up, and one little lemon cell just isn't strong enough to provide it.
But hey, don't get discouraged. Science has a really cool and, well, super powered solution for us. If one lemon isn't enough power, what do you think we do? Yep, we build more. It's time to create a super lemon battery. So for our next step, you're just going to do exactly what you did before, but 2 more times. Go ahead and build 2 more identical lemon batteries. When you're done, you should have a grand total of 3. So how do we actually combine their power? We're going to connect them in series. All that means is we're linking them end to end, connecting the positive side of one battery to the negative side of the next. It's just like stacking batteries in a flashlight. Each one you add gives you a bigger boost in total voltage. And here's exactly how we do it. You're going to take the copper wire coming from the pennies of your first lemon and wrap it tightly around the nails of your second lemon. Then you just do the exact same thing again. Connect the copper wire from lemon number 2 to the nails on lemon number 3. You're basically making a power chain.
Okay, we've built our 3 battery cells. We've connected them all up in series. This is it. This is the moment of truth. Let's see our super lemon battery in action.
Okay, for this final connection, remember how the zinc nails are negative and the copper pennies are positive? Well, in our chain, the nails on that very first lemon are our overall negative terminal, and the pennies on the very last lemon are our overall positive. So carefully touch the negative wire to the shorter leg of the LED and the positive wire to the longer leg. And there it is, a glowing LED. It actually works. You just took some lemons, nails, and pennies and literally generated your own electricity to create light. How amazing is that? That is fantastic work.
So we got the result we wanted, which is awesome. But the really big questions are still kind of hanging in the air, right? Like, how is this even possible? How does a lemon make electricity, and why was 3 the magic number of lemons?
We've seen that it works, but the real fun is in how it works. So here's a quick preview. Basically, the acid in the lemon juice kicks off a chemical reaction between the 2 different metals, the zinc in the nails and the copper in the pennies. This reaction literally pulls electrons from one metal and pushes them to the other. And that flow of electrons, well, that's an electrical current. And by linking 3 lemons in series, we were able to stack up their voltage to get enough push to finally light up that LED. Now, there is so much more fascinating science to uncover, and we'll dive way deeper into that chemical reaction in our next explainer. Thanks for building with me today.